Hello, chemistry students. I'm going to dive into an introduction of Chapter 7. Even though we're coming up on Christmas break, I think it's nice to have a little introduction here. So we're going to focus on identifying the number of valence electrons, which we've kind of talked about that already. Identifying atoms that tend to gain or lose electrons, and describe how cations and anions form, and actually what those words mean. So as you probably remember from previous years in science, ions are atoms or groups of atoms that have become charged in order to achieve something called a stable octet of electrons. All atoms like to have a full outer energy level or a stable octet. And so they're either going to gain or lose electrons in order to achieve that status. The only electrons that they gain or lose are the valence electrons. So if I look at an atom of sodium, if I look at I'm going to draw just the Bohr model, even though we kind of learned that that's not super accurate, but it is kind of the easiest to work with. So looking at sodium, which if we look at the periodic table, sodium has an atomic number of 11. So I know there's 11 protons and 11 electrons. So that first energy level holds 2, the second energy level holds 8, hopefully that's 8, and then the third energy level, of course, will hold 18. However, we only need 11, so we have 2 plus 8, which is 10, and then this one, which is 11. So it wants to have 8 in this energy level, but it only has 1. So it's either going to pick up 7, which would never happen. Like, that can't happen. It's just, it's too much of an offset of charges between the positive and the negative. So what happens is it is going to drop this 1 electron. Now this sodium has, it still has 11 protons, but it only has 10 electrons. Electrons are that negative charge, so essentially it has 11 of the positive charges, but only 10 of the negative charges. So my overall charge here is a +1. So that's how it would form a positive ion. Something like chlorine would be the opposite. So if I look at where chlorine is on the periodic table, chlorine has an atomic number of 17, and it's way over on the opposite side where sodium is over here. So if I look at chlorine electron configuration, chlorine has 7 valence electrons. So in order to achieve a stable octet, it either needs to lose all 7 of these, which is never going to happen, or it's going to pick up 1 more to complete this outer energy level. So that's actually what's going to happen. So we're going to put another electron here, and now we have a stable octet. But now chlorine still has 17 protons, or positive charges, but now it has 18 negative charges, giving it an overall charge of -1. So, actually, let me get rid of this really quick. So we actually then say, when we talk about positive and negative ions, there's actually separate terminology for those. Cations are positive ions, so we always remember cats are positive. Anions then are negative ions, and I always remember onions are negative. So cats are positive, cations, and onions are negative. So anions would be those negative ions. So how do we combine those in order to cancel out the charges? Because that's why ions combine, is because they're oppositely charged. So we have something like sodium, which is a positive ion, chlorine, which is a negative ion. Remember that this has an overall charge of +1. This has an overall charge of -1. So we add them together, that equals 0. So these two will simply combine in a 1-to-1 ratio in order to cancel out that total charge. So this is pretty simple. We do, however, have ions that are a little bit different in charges. So what about if we have something like magnesium, which has a 2+ charge, combining with, think about this, let's say oxygen with a -2 charge. So this also, this is a +2, this is a -2. If I add these together, I get 0. So these two also would combine in a 1-to-1 ratio, because it takes one of the +2s and one of the -2s to equal 0. What about if instead of oxygen, I have let's say chloride with a -1. So now I have a -1 charge. I need to think about how many of each of these do I need to combine to equal 0. Well, clearly it's not a 1-to-1 ratio. I'm actually going to need 2 of these -1s and only one of the +2s to equal 0. So I'm going to need 2 of this one of the magnesium, but 2 of the chlorine in order to equal 0. There's a cheater way to do this. You probably talked about called the crossover method, which works really well. So if I have, this is a +2 charge, this is a -1 charge. If I just do take the 2, cross it over, put down here, this is going to be a 1. In the final formula, however, we don't write the 1. We never write a 1. We just, if it's not written, we just know it's a 1. So MgCl2 using the crossover method. So you can see I get the same answer using that crossover method. One caution I would say, be very careful if you're using the crossover method. If you do magnesium and oxygen, if you used the crossover method, we put a 2 down here, we put a 2 down here, but remember we said if I have a +2 and a -2, I only need 1 of each of these to equal 0. So in this case, we have to reduce. Do not forget to reduce these to the lowest whole number, the lowest whole number ratio. That says reduce. It doesn't look like it though. The lowest whole number ratio that I can combine these in. So obviously if this is a 2 and this is a 2, we reduce them to each be 1. And that's how we come up with that. So be careful in combining those. But this crossover method is especially helpful if we're doing something, you know, like something that's a +3 and a -2. So for example, if I'm combining something like aluminum, which is a +3 or 3+, sorry. and an oxygen, which is a 2 minus, plus 3 minus 2. I can still do it this way, but I got to really think about, there's like I'm going to have to put coefficients in front of both of these. This ends up being 3. I got to put a 2 in front of here, multiply those, right? 2 times 3 is plus 6, 3 times negative 2 is minus 6, and that's how I'm going to get the 0. But it is easier with these to just do the crossover method. And so this, yeah, becomes Al2O3 as a final product. All right, that's the quick, skinny overview of monoatomic ions. So hopefully this is enough background for you to easily complete the first worksheet. Good luck.